Hello everyone. So in the last video we have seen data augmentation techniques. Now in the next video we have another concept that is the normalization. So in this video we will see what is the impact of normalization. On the top of it we will see the vanishing and exploiting gradient problem as well. So let's see in details. So once we have data we need to normalize it. Now you can say what is the purpose of normalization? Why we need to normalize it? So let's take one example. Suppose we are trying to solve house price prediction problem. Now in that case, in house price prediction problem, suppose we have one attribute or you can say one feature is the size of house. So that will be in the 1700 square feet or 2100 square feet or 2300 square feet. Number is little bigger. Now suppose we have another attribute that is the BHK. How many BHK? So you can say 3 BHK, 5 BHK, 6 BHK, 2 BHK, something. So you have a number that is a tiny number. Now this can be another feature that is the distance from the school. Maybe say one person say 1 kilometer, another society say 0.5 kilometer. So again it's a small number. Now, once you try to make a neural network which has the higher value, so you can say if your x1 is here, you have x2 is here, you have x3 is here. Now, if you say we are trying to make a model, we have w1, w2, w3. Now, if you have x1 value is very large, in that case, the impact on this output of this x1 will also very large. So now once you do the back propagation, w1 will have very high impact. So that is not a good idea because all features have some impact. It should not be only one feature have higher impact. So how to solve this? In order to solve this problem, we are trying or we are doing the normalization, right? On the top of it, the normalization will also distribute your data in a well-mannered way so that your algorithm or your model will train well. So suppose we have this data. Now this is not normalized data. So once you do the mean subtraction, it will be normalized with the x-axis. Now once you do the normalized variance, if you try to normalize the variance, then it will be normalized with both x and y axis. Now once you have normalized data, then it will perform much better. On the top of it, normalization means you are taking value between 0 and 1, all the values between 0 and 1, so that one algorithm will not impact a lot, right? So on the top of it, if your values become smaller, then that will have very faster training as well, because now your model is not focusing only on one data or you can say one weight or fewer weights. It is focusing on all the weights because their input values are in the same range. So that's the power of normalization. Now let's look into the vanishing and exploiting gradient. So while we are trying to update these weights, like these weights, these weights, these weights, these weights, or all these weights while we are doing the back propagation. So once you update these weights, you will see in order to compute the y cap, these all weights are multiplying, right? Now this is really a small network. If you have very dense network and very high depth network, then maybe you have 100 layers. Now what will happen? Let's look into this. Suppose your one weight value is less than 1. In that case, once it multiply zero point 0.5 with zero point 0.5, it will become 0.25. Then 0.25 into 0.25 will become 0.125. So continuously it is decreasing and decreasing. And once your gradient is decreasing and decreasing, that is known as vanishing gradient problem. Now, on other hand, if your value of gradient is more than 1, and once they will multiply, they will become very high value, and that is known as the exploiting gradient problem, right? So in order to make them, or in order to take care or solve these problems, in case of exploiting gradient, we have a clipping method. If your gradient is going beyond a certain threshold, we'll clip it. We'll not allow them to go beyond that. That is to control the exploiting gradient. Now, in order to control the vanishing gradient, we have different methods. One method, you'll have that your weights will have variance between 2 by n, so that your weights will be distributed. On the top of it, there are as one method, or you can say one activation function as well, that is ReLU. As we know, ReLU has, if it is a positive value, then it is equal to the weight, whatever input is coming, and if it is negative, it will become 0. So as this section will help us to solve the problem of vanishing gradient, because it is passing the same value, it is not reducing them further. So in that way, we are trying to reduce the problem of exploiting gradient and vanishing gradient. Thank you. We'll catch you in the next video.